Hello guys, today we are going to discuss the job number 2, that is actually the experiment number 1, because your job number 1 was related to the layout of the fluid mechanics lab, and also I have given the demonstration about that particular job number 1. And now today we are going to discuss about the second job, that is about the performance of certain to determine the certain different physical properties of the fluid. The title of the job number 2 is to study the various properties, physical properties, density, specific weight, specific gravity, dynamic viscosity and kinematic viscosity of a fluid. The objective of this experiment is to study the properties of the fluid and to determine its viscosity. To achieve this objective, we are going to use the certain operators to perform the experiment. The list of the operators that we are going to use for this particular job is the redwood viscometer. Here also in the job layout we have a certain brief description about this redwood viscometer that was used to determine the various physical properties of the fluid, and the main property is the viscosity, because if the viscosity is known to you, then related to those the density, specific weight and specific gravity you can also determine, and if the mass density is known to you, then the kinematic viscosity can also be determined. Before performing this experiment and to understand the demonstration and instructions of this particular job, you must go through with the second part of your theory lecture of your chapter number 1, the physical properties or the properties of the fluid. For those, you need to have an idea about all those physical properties that we have discussed in detail, their formulae, how to determine, that we have discussed. So for this particular job, if the formula will be with you, then we will discuss about the performance procedure, and by taking the input data, and after the performance of this experiment, you can have a certain set of the input data. By using this input data, you can calculate these physical properties given in the title of this job by applying the corresponding formula. Okay, so here the operators is redwood viscometer. So here in the figure you can see, when you will come in the final semester, then again one by one you are going to perform this experiment. There I will be going to again give you demonstration in the lab, and you will see by person that particular viscometer. So here you can see a container and the vessel at the top. Okay, so the fluid is going to be filled in this container, in this viscometer, in the top part of it, and at the bottom you can see here one nozzle or one opening, and from this opening here we are going to place a flask in this plate. Okay, here you can see a frame or one stand. Here we are going to put a flask, so that the fluid that we are going to be filled in this container, in this viscometer, needed to be poured down, needed to be allowed to fell down. Okay, just to be go through with this opening and to be put into this flask putting over here. Okay, and then we are going to note down the time, how to relate the viscosity with the time of flow of the any particular fluid we will discuss in this job. Then beakers, stopwatch just to note down the time, weighing balance to weigh the beaker, the flask and a certain fluid, thermometer to check the temperature of the surrounding. In related theory, all of the physical properties that we have discussed in the second part, particularly in the second part of the theory lecture, chapter number 1, those are going to be repeat. You need to be just repeat over here. That first one is the mass density. So again, the density of the fluid is defined as the mass of the fluid per unit volume. That will be mf over vf. F in subscript is going to represent the fluid, and m is the mass density, v is the volume, rho is the density, and f is again for the fluid. Units are kg per meter cube. Second, specific weight, gamma. Specific weight of the fluid is defined as the weight of the fluid per unit volume. So in the subscript, F is going to represent the fluid. The unit is Newton per meter cube. Specific gravity, again the ratio of the weight of the fluid and the weight of the standard fluid at equal volumes. It is also defined as the ratio of specific weight of the fluid to the specific weight of the standard fluid. It is also defined as the ratio of the density of the fluid to the density of the standard fluid, with no units at all. And in case of liquid, standard fluid is water. Next is dynamic viscosity. Dynamic viscosity is also known as absolute viscosity. That is the friction offered when one layer of the fluid tries to slide over another layer. According to Newton's law of viscosity, shear force is equal to mu Va over y, and we have discussed in detail about this. Units in theoretical part. So if you have any confusion about this formula and this equation and how we have derived, you can take a reference from the lecture, theory lecture, that is the part 2 of your chapter number 1. Units are given over here in all of the systems, different systems of units. Kinematic viscosity, mu. It is the ratio of the dynamic viscosity and the density of the fluid. So mu f over rho f. So its unit is Stokes. Now, the schematic diagram of the tube type viscometer, that is redwood viscometer. So here it is also called as tube type viscometer because I have told you that at the bottom of this container of the viscometer there is a nozzle or there is an opening, and from this opening you can collect the fluid at the bottom by placing a flask underneath. So there is a certain diameter of this container. This is a circular container of the viscometer, in which the one circular container you can see at the top. This circular container has a certain diameter, and you are going to put your weighted floor, already weighted liquid you are going to be put into this container at a certain height, with a certain height that may be h, capital H. And then further you need to allow the fluid under the gravitational forces to flow down or to go through with this opening and just to be poured down into the flask underneath. Okay, so here we are going to see in this particular diagram different parameters. One by one we will discuss. Small d at the top, you can see it is the diameter of the container or the cylinder in which the fluid is going to be put down. Then is capital D. Capital D is the diameter of the smaller tube at the bottom of this cylinder or container. So okay, so its own diameter is there, that is the smaller diameter, capital D. Capital L is the length of the tube, that is length of the tube for this particular opening that is over there. Small h is the drop in the height of the fluid. First of all, there will be a level. This solid line is going to show you the initial level of the fluid. After allowing this fluid to pour down, we are going to be observe the certain drop in height of this particular fluid within the container, and this is equal to small h. This dotted line is going to show you the height of the fluid, level of the fluid after dropping, and this solid line is going to show you the level of the fluid at the initial stage. Then we have small h and subscript capital H, HL. HL is the average head causing flow. That is the average of these two levels, the initial level and the final level of the liquid, and the average of both of these from there at the just opening point where the nozzle or where the smaller tube has its opening till there. This is going to be called as average head causing flow. Now capital V and capital L in subscript, that is VL, volume of the fluid collected in the flask in time t. So VL is to be calculating is very simple. If you have flask, its volume will be equal to the volume of the fluid. T is the time of collection that you are going to be measured by the stopwatch. Now procedure. Actually what you need to do, the step number 1 is to take some quantity of the fluid, any type of the fluid, in a beaker on which the experiment is to be performed. So what you need to do, first of all, you need to weight the fluid with the beaker. First of all, you need to weight the beaker without the fluid and then you need to put the quantity, a certain quantity of the fluid into the beaker, and then with the fluid and beaker, the whole together, the weight you need to be determined. So the two weights will be with you, only beaker and fluid plus beaker. Number 2, set a choke at the mouth of the tube to control the flow of the fluid. So at once, if you are going to pour your fluid, so there will be not you can say possible for you to switch on the stopwatch. First of all, you need to pour all of the fluid into the container. So till then, what you need to do, you need to close the opening of the tube from the bottom of the container. So for that purpose, you need to choke it. So you can use any kind of paper, any kind of wood piece, so just to be choke it or just to be stop it. So any kind of stopper you can use for that. Number 3, level the instrument by ensuring the position of bubble in the center. Okay, so leveling of the instrument is very important. So the time of flowing of the water, any liquid from this viscometer can be disturbed if your instrument is not leveled. So you must level your instrument by using the level bubbles. Okay, so like in swimming you are going to use just kind like that. So just ensure the leveling of the instrument. Number 4 step, pour the fluid in the cylinder up to the pointed edge of the indicator. So where wherever the indicator within the container is there for the initial or the level of the liquid, you need to be just put there. That will be marked on the container. Then you need to put a flask under the other end of the tube, mean at the bottom of the viscometer, to collect the fluid in the measured time t in a fixed quantity, 50 ml, and adjust properly. Okay, so we have the quantity also fixed, that is 50 ml, and you need to just note down the time. So that beaker or the flask that you are going to be putting down at the bottom, it has a known quantity, that is 50 ml. So 50 ml volume you are needed to be collect within a particular time. So for each kind of the fluid, if 3, 2, 4 or 5 types of the fluids you are using to determine the viscosity, so for the fixed quantity, fixed volume, the time will be different, of course. Number 6, now take a stopwatch and set it to 0. Now immediately remove the chalk, that stopper, and start time counter at the same time. So what you need to do, you need to just get ready your with your stopwatch. Your stopwatch, you need to just switch it on. Okay, first of all set it at 0, and then you need to just at the same time you need to do these both steps, removing of the stopper or the chalk, and then you need to start the counter. So both should be at the same time. If there will be a lap of the time, then the reading will be disturbed. Number 7 step, measure the temperature of the surrounding using a thermometer and also note down time for the fixed quantity. So at that particular time, once you are going to be start your stopwatch, at the same time you need to just install or fix a thermometer over there, and you need to note down the temperature reading. Number 8, measure the weight of the fluid along with the beaker and subtract the weight of the beaker from it to obtain the weight of the fluid. Okay, so that you need to do, I have told you. Now some mathematical calculations. If you want to get the volume flow from that particular tube or from any cross section, if a certain pipe will be there, if the open channels be there, then for the closed conduits, especially closed pipes, we have actually a formula for the discharge. Here, this first formula given in this slide is going to represent the discharge or the flow of the fluid from any closed pipe. That is equal to pi d4 gamma HL divided by 128 mu L. Okay, so what this Q is actually, this is the volume of any liquid or any fluid passing through any cross section in unit time. If it is, you can say, the rate of flow of water, rate of velocity of the water. So if the flow is needed to be determined, then what you need to do, you need to first of all fix the time in unit time, how much amount, how much volume of the water is flowing through a particular cross section. So similarly, this actual phenomena of this experiment is also going to relate with the flow of the water, flow of the liquid, flow of the liquid, particular liquid. So for that particular fluid or the liquid, what you need to do, you need to determine the collected volume in terms of discharge. So you need to start with the discharge at first. Then this discharge you can replace with its own formula, or with by its definition, that what is Q? Q is the discharge. And what is discharge? Discharge is the flow of the fluid, and how this flow of the fluid is going to be determined by the passing volume through a cross section in unit time. So VL over VT. Rest will remain the same on the other side of the equation. Now from this equation you can take out the mu and all other parameters on the other side of the equation and mu on one side. So keeping the mu on one side of the equation and taking all on the other side, you are having this form of this equation, that is mu is equal to pi d4 HL gamma t divided by 128 VL over capital L. Now mu is equal to kt gamma t. If you are going to take out from this equation gamma t, separate out, and only this constant parameter with you, so that will be equal to kt. Now what is kt? This whole term. This kt is tube type viscometer constant having units of length, as VL is equal to pi d square h over 4. So in this, pi is constant, dia of the container is constant, height of L mean average head is constant, 128 is constant, L is constant. What is left with us? That is VL. So VL can be determined by pi d square h by 4, and again h is constant. So if everything is constant or variable, like let's suppose, then still you can determine the kt by this formula. So h is equal to 4VL over pi d square. Okay, so from there you can have the formula for the h. So small h is equal to 4VL over pi d square. Hence HL, how to determine the HL? That will be capital L plus H1 minus H by 2. So all of these values are with us. These will be your input data and you can determine very easily. Now what is left with you? Gamma is the constant again, and what is T? Now T, time, you need to measure by the stopwatch. So the time is the indicative of the viscosity. So if you are interested to determine the mu, then this formula will be there. If you are interested for the kinematic viscosity, this is dynamic viscosity. If the kinematic viscosity nu is needed to be determined, then mu over rho. We are already familiar with this formula. So what you need to do with the mass density unit, divide it. So you will get, after simplifying it, kt gt. Okay, g is the gravitational acceleration. I'm going to give you just after the end of the slides, okay, separately in your WhatsApp group or the email, I'm going to give you a certain random values, input data, okay, and also the observational values for this experiment. You need to do the practice at home, and you need to send me the table of calculations so that I'm going to make some corrections for you guys. If you are okay with this practice, so that it is going to make you an easier calculations at that time when actually you are going to perform. Okay, so I'm going to send you a random number of calculations and random values, input data for this experiment. Just do practice for it to calculate all of these values, and then for the performance point of view, we will do it when you will be on campus. Thank you so much, guys.